In this chemical equilibrium, we're given a reaction and asked to answer several questions. So for part A, we want to write out the equilibrium expression. This is products over reactants. Now keep in mind that we don't include solids or pure liquids in the equilibrium expression. So H2O is a gas. We raise that to the third power because of the coefficient of 3 here. We divide that by reactants. Hydrogen also has a coefficient of 3. The other two reactants, the other reactant is a solid, so we don't include that. So that's the expression for the equilibrium. Question B says, what will happen to things if we add more iron? Iron's a solid, so no change. The concentrations of everything will be exactly the same. C, what will happen to the concentration of each reactant and product at equilibrium if H2O is removed? So if we remove H2O, first of all, the H2O concentration is going to go down. Now, if the H2O concentration is removed, this reaction will shift right. So therefore, if this reaction shifts right, hydrogen concentration is going to go down. For part D, what will happen to the concentration of each reactant and product at equilibrium if H2 is added? First of all, if we add H2, the concentration or pressure of H2 is going to go up. Now, if we add H2, this reaction will shift right. Which means that the concentration of water vapor is going to increase as well. Part E, what will happen to the concentration of each reactant and product at equilibrium if the pressure on the system is increased? All right. Now, what you'll see here is that, let me switch to a blue pen. The balanced chemical equation has a 3 here in front of the hydrogen, which means there's 3 moles of a gas on the left. And the balanced chemical equation also has a 3 in front of this gaseous substance, so there's 3 moles of a gas on the right. Now, since we have equal number of moles of gas on each side of this chemical equilibrium, there's going to be no change. So if we increase the pressure, there's going to be no change in position. F, what will happen to the concentration of each reactant and product at equilibrium if the temperature of the system is increased? First of all, the delta H is given to us, and that has a positive value. A positive delta H means endothermic, which means heat is a reactant. So let's rewrite our chemical equilibrium with the word heat here as a reactant. All right, we've got this all set up to think about it. So what will happen to the concentration of everything if the temperature is increased? So if we increase temperature, that's the same thing as adding heat. Which means this reaction shifts right, sorry about that, shifts right. Shift away from the increase. So that means the concentration of hydrogen is going to decrease and the concentration of H2O is going to increase. So that's how you think through these problems on Le Chatelier's principle with number 44 in the OpenStax book.